Hello and welcome. Today, we are diving into one of the most game-changing ideas in all of modern software, containerization. Seriously, if you've ever wondered how companies push out new features so fast and so reliably, well, you are in exactly the right place. Let's get into it.
All right, let's be real. If you've ever written a line of code, I guarantee you've either said this or heard it. It is the classic, hair-pulling, frustrating problem where everything's perfect on your laptop, but the moment it hits a testing server or production, it just breaks. It's a total nightmare. So what on earth is the solution?
You guessed it, containerization. This single, powerful concept is designed to kill the works on my machine problem once and for all. It gives us a consistent, super reliable way to get our software out the door. And in the next few minutes, we're going to break down exactly how it pulls it off. So first things first, what is a container? The easiest way, honestly, to picture it is like taking your entire application and putting it inside its own perfect, self-contained little box.
Let's unpack that a bit. A container bundles up your application's code, sure, but it also packages every single thing it needs to run. All the libraries, the configuration files, the system tools, you name it. And the magic words here are lightweight and portable. It means that this little package, this box, will run exactly the same no matter where you put it.
And this is the mantra, the core philosophy behind it all. You create that application package, your box, just one time, and from then on, you can be totally confident it's going to run exactly the same on your laptop, a coworker's machine, a test server, or deep in the cloud. Anywhere.
Now, to really get why containers are such a big deal, you have to compare them to what we used before, virtual machines, or VMs for short. The difference here is huge, and it's all about efficiency.
Okay, this is the crucial part right here. A virtual machine, on the left, has to boot up an entire separate guest operating system for every single app. Think a whole copy of Windows or Linux. That is incredibly heavy and super slow. Containers, though, they're much smarter. They all just share the kernel of the main host operating system. This is what makes them so ridiculously lightweight, lightning fast to start, and way more efficient with your resources.
So the idea of containers is amazing. But what's the tool that actually put this power into the hands of millions of developers? Well, that would be Docker. Docker is the platform that took this concept and made it simple, accessible, and frankly, a joy to use.
So why did Docker become so popular so fast? It's simple, really. It gives developers exactly what they need. It's pretty easy to learn, it makes deployments incredibly fast, it is without a doubt the industry standard, and it makes scaling and moving your apps around a total breeze.
Okay, so we know containers are efficient, and Docker makes them easy. But how does Docker actually, work under the hood? Let's take a look at its architecture. It's surprisingly simple, but really powerful.
It really comes down to these three main parts. First, there's the Docker client. That's you, typing commands into your terminal. Those commands get sent to the Docker daemon. That's the engine, the workhorse doing all the heavy lifting in the background. And that daemon manages everything, often pulling these pre-built application blueprints, called images, from a Docker registry like Docker Hub.
So what does this look like in the real world for a developer? Well, the day-to-day workflow is this beautiful, elegant three-step process: build, ship, and run.
First, you build an image. Just think of an image as the static, unchangeable blueprint for your application. It's the master recipe. Next, you ship that image, which just means you push it to a central library, a registry, so anyone or any server can grab it. And finally, you run the container. This is when you take that blueprint and bring it to life as a live, running instance of your application. Build, ship, run. It's that simple.
Let's make this totally real. That build step translates into a command that looks just like this. Docker build reads instructions from a special file in your project, and then it creates that blueprint, our image, and we give it a name or a tag like my app.
The ship step, just as easy. The Docker push command takes that image you just built and uploads it to a registry. Bam! Now it's available to be deployed absolutely anywhere.
And finally, this is the magic moment. Docker run my app. You're telling Docker, hey, take that blueprint and launch it as a live running container. And just like that, your application is officially up and running in its own perfectly isolated world.
Okay, let's zoom out now and see how this all fits into the bigger picture. In a real DevOps world, you're not typing these commands by hand every time. Instead, they're all automated as part of a CI/CD pipeline. That stands for continuous integration and continuous deployment.
This flow is a perfect example of a real-world pipeline.
So a developer commits their code. Right away, an automation server, something like Jenkins, kicks off and builds a brand new Docker image. That new image gets pushed to a registry. And finally, an orchestrator, like the famous Kubernetes, grabs that new image and deploys it as a container into production. It's this beautiful, automated flow from a developer's keyboard all the way to the customer.
So after all that, what are the big takeaways? Why does this matter so much? It's all about portability and consistency. Your app just runs the same everywhere, which kills that old developer problem. It brings incredible speed to your deployments. We're talking seconds, not hours. And it gives you massive efficiency, letting you squeeze more performance out of your hardware. This is exactly why it's the heart and soul of modern DevOps.
And there you have it, a whirlwind tour of containerization from start to finish. If this explainer helped things click for you, do me a favor and hit that like button, and maybe share it with someone else you think could use it.
We are building out the entire DevOps roadmap right here, so make sure you subscribe so you do not miss the next explainer in the series. Thanks so much for watching, and I'll catch you in the next one.